Hi, my name is Thomas Hickey, and I'll be presenting a literature review on the future of rooftop greenhouses. This is part of the class Green Roof Culture, Hort 511 at Colorado State University. The objective of the review is to provide a foundational explanation of urban agriculture and rooftop agriculture with a strong focus on rooftop greenhouses. I'll be highlighting the opportunities and also limitations that rooftop greenhouses can bring into urban landscapes through current technologies and hypothetical future applications. A quick list of terms that will come up throughout the review. RTG, or an RG, is a rooftop greenhouse. CBA is a cost-benefit analysis. LCA, life cycle analysis. BIPV, building integrated photovoltaics. SRG is a smart rooftop greenhouse. IRTG is an integrated rooftop greenhouse. I've split the review into three different sections: rooftop agriculture, RTG food production, and RTG future considerations. So to get started with urban agriculture, it can be defined as the practice of cultivating, processing, and distributing food in or around urban areas. There's an entire spectrum of different urban agriculture operations. It can be anything from a community garden to an entire building integrated vertical farm. But for this review, we'll be focused right in the center area, starting with rooftop agriculture, but then moving into rooftop greenhouses. Section 1, rooftop agriculture. So the first literature source, Challenges to Science and Practice regarding rooftop agriculture, that is, the paper outlines opportunities and challenges for advancing the science of these constructed ecosystems with a particular emphasis on rooftop agriculture. This paper, they started off with the section Novel Ecosystems, and those are essentially just ecosystems that have artificial and natural components like a green roof. Many urban landscapes also fall into this category as they include both artificial and natural components in the built environment. They note that collaborative research is needed if we want to fully understand these new ecosystems in urban settings. The next section is rooftop farming, something that we've learned about a little bit in this class already. Basically, the production of fresh vegetables or herbs or fruits on top of roofs. And this provides unique marketing strategies like organic cultivation or farm to table type of stuff. It is an opportunity because of the limited space and competitive real estate markets that exist in urban centers. And rooftop farming also could provide extra tourism, more environmental education, green job training, culinary events, nature therapy, or even help liven up the neighborhood. The next section, they title it Hypothetical City Scale Effects. They looked at a study in Bologna, Italy, which suggested that they could transition 82 hectares of roof space into rooftop agriculture. And with that, it would provide 77% of the city's fresh vegetable demand. Then another study based on New York City, they estimated that if all roofs that could be cropped were dedicated to only mixed greens, then those roofs could provide 38% of New York City's demand for mixed greens. So New York City, a little bit more populated than Bologna, Italy, with a lot more high rises and not too much surface area on those roofs. Also a shorter growing season. And then lastly, rooftop greenhouses, getting into the topic of this review. They claim that rooftop greenhouses could achieve higher yields, better water efficiency, and higher stormwater retention rates. However, the construction cost of a rooftop greenhouse can be much higher than that of open air commercial rooftop farming. Now, the second piece of literature that I've reviewed is um, called Rooftop Greenhouses Idea, Planning, and Implementation. This came out of Germany. It's a 56-page document that provides support to stakeholders, experts, decision makers, and citizens for the practical implementation of RTGs. So on the right, you can see the outline of that document, everything from development and planning to site analysis, decision making, marketing, production planning, financial planning, and then finally project support. So really an all-encompassing document here. Again, another graphic on the right from this paper really breaks it down and walks anybody who might be interested in this through the process and what they'll need to do to make it happen. Again, the document is aimed at German implementation, but it could be used as a framework for anywhere across the globe, especially in America. I think we could follow this framework, and it aids in the implementation of these concepts through recommendations for direct action, which is awesome. A great resource. So now getting into section 2, the actual rooftop greenhouse food production, and looking at some literature on that. So the third literature source is titled Eco-Efficient Year-Round Crop Combinations. It's published in the International Journal of Life Cycle Assessment. And in this study, they set out to analyze vegetable production in RTGs over 4 years to determine different crop combinations that minimize environmental impacts while also diversifying food supply. Their methods, they evaluated environmental performance of 25 different crop cycles, including 7 species. They did consider 2 subsystems, the infrastructure and also the operation. Some of the conclusions that they came to were that by increasing the diversity of the system, it led to better environmental performance of the greenhouse urban ag. Overall, spring tomato cycles had the lowest impacts in all categories, and then spinach and arugula had the highest impacts. This took place in Barcelona, so you can imagine spinach and arugula are more cool season crops, might have a higher impact because of that. The fourth lit source is titled Ecological Network Analysis of Growing Tomatoes in an RTG Setting. And in this study, they analyzed energy flows for growing tomatoes in an RTG. And they used a LCA, a life cycle assessment, to identify different flows within that supply chain. Some of the big takeaways and some of their methods included analyzing the food, energy, water nexus in urban agriculture. And they studied that through inter-industry flows. Overall, one of the more exciting takeaways that I got from this was that energy dissipation could be improved through the use of renewable energy. And they stated actually by including solar energy, it could be reduced. So I thought that was very exciting. Here's a graphic from the study, kind of the differences in ecosystems. You see a natural ecosystem on the left, and then tomato production, and an urban RTG on the right. And they chalked up these differences mainly to the use of fossil fuels in the system. You don't have that use in a natural ecosystem. Now, moving on to the fifth literature source, a feasibility assessment of RTGs in Latin America. And this actually took place in Quito, Ecuador, which is Ecuador's capital city, so pretty sizable city. And the purpose of this study was to identify the implementation potential of RTGs and social neighborhoods within Quito. So they characterized based on their set criteria, determined the available surface area, and then they analyzed production, self-sufficiency, and self-supply. Overall, they analyzed just one neighborhood. 33% of that neighborhood could be turned into rooftop greenhouses. And with those percentages, they could then supply 4.5% of Quito's total demand of tomato and lettuce, which came out to be 1.5 million kilograms a year of tomatoes and 56,000 kilograms a year of lettuce. And now, Section 3, RTG Future Considerations. Probably my favorite section that I got to review. So, the sixth source here is a cost-benefit analysis of food production versus energy generation. So they conducted a cost-benefit analysis on various types of rooftop agriculture compared to rooftop BIPV, which is building integrated photovoltaics. And this took place over a 50-year time span. This is a graphic from the study. You can see it's exemplified all the different types of roofs that they considered. On the left, just a basic roof, and then rooftop farming, unconditioned RTGs, conditioned RTGs, and BIPV. So the cost benefit analysis was split into two sections. First one was direct effects incurred by the operators of the system. This would include investment costs, operational costs, carbon costs, and also the profits from all the food yield. And then the second was societal effects on the local community. And these would include impacts on households, savings from food expenses, local jobs created, and environmental impacts. And then the results, probably the biggest takeaway is that food production was more beneficial than energy production, but they also recommend that every site should be assessed on a site-by-site basis. Next, they say that RTGs can provide the most short-term and long-term benefits when compared to open rooftop ag or rooftop photovoltaics individually. Some things that went into their decision-making process, again, that really made RTGs stand out was the year-round job creation, the scale of production, the added property value, and other supply chain considerations. So the seventh source of literature, rooftop greenhouses to improve buildings' metabolism. This one also took place in Barcelona, and it's an article that presents the first results from the research project titled Fertile City, which aimed to analyze, from a technological and sustainability approach, a new ag production system for Mediterranean urban areas through the integration of greenhouses on the roofs of buildings. Here's a graphic from that study highlighting the exchange of flows. So they have the G is gas, talking about CO2, kind of switching in between the rooftop greenhouse and the labs and offices below. There's also a flow of water and energy or electricity. So the content of the article included an innovative system, which is called an IRTG, the Integrated Rooftop Greenhouse. Those things include energy, water, and CO2 in the metabolism of the building. And it aimed to demonstrate the potential of IRTGs to quantify their environmental and social benefits, as well as how they could change the image of our cities overall. Some of the conclusions that they came to: the life cycle analysis demonstrated that from cradle to consumer, locally cultivated tomatoes in an IRTG were actually cheaper and had lower environmental impacts. Another key takeaway is that the thermal inertia from the building underneath the greenhouse actually helped keep the greenhouse warm throughout the winter due to the reinforced concrete slab. This is something that does not occur in conventional greenhouses. Now, the eighth and final literature source is titled Smart Rooftop Greenhouses as Technology for Industrial Energy Symbiosis. So now we're getting into SRGs. In this study, they looked at SRGs as a solution for advancing industrial energy efficiency and energy flexibility of production systems by connecting independent production systems and local supply systems into energy networks. So the content in this one, they stated that SRGs can innovate the combination of biomass production and waste heat usage from a factory, as well as smart grid integration into a collaborative production system. SRGs allow for space to be used more efficiently. And the energy symbiosis from this, you integrating SRGs into a microgrid together with other manufacturing processes below. And they suggest that an interdisciplinary research approach combining these two things are needed if we want to move forward with high-tech urban. This is a graphic from the study essentially highlighting the transition of flows of energy, waste heat, temperature between the smart rooftop greenhouse and manufacturing processes. You can see the heat from the processes goes up into the greenhouse, and in return, they're suggesting that bio-based manufacturing materials are then returned. In a perfect world, that would be awesome. But also those plants up top could be used for many other things, like feeding employees or feeding the community nearby. And then at the bottom, they have the smart grid that would also be incorporated into this system. So that concludes the literature review, but I did want to include section 4 here, real world application, highlighting Fox Park in Denver, Colorado. This semester, I had the opportunity to work with a group in the class Horticultural Crop Production. And with that class, we put together a cost analysis for solar in a rooftop greenhouse for this proposed development. So I must state that I do not own the rights to any of these photos, nor did I make any of them. I'm just presenting them to you guys to show how RTGs could actually be used in the future here in some pretty close to home applications. So just highlighting Denver, the location of the site, Fox Park. Again, if any of you are familiar with Denver, this gives you an aerial shot. It is an old industrial area, so that goes right along with the last part of the lit review too. An old printing plant building is going to be refurbished and included into the development. So here's a plan view of the site, and you can see they're proposing a 35,000 square foot rooftop greenhouse. Very cool. Here's a section view. Again, you can see the RTG on the right there in green. And now a perspective view. The RTG is in the back right, kind of peeking out, but this gives you an idea of the architecture overall and how it is incorporated right into that building. And yet one more section view. The RTG is on the far left side there. And yeah, they're proposing rooftop greenhouse space and also potentially some solar on top of the greenhouse or in addition to the greenhouse, which could power that system or provide power to all the other activities that are going on in this site. That concludes my presentation. Thanks for listening. Here are my sources.